Hello, this is team number 2, and today we'll be presenting our first homework. So it's much easier to explain in a notebook, so we decided to go through the Jupyter notebook, and at the end we'll be running our program on server. So first we created this function called generate chunk, whose functionality is that it takes a file and it splits the file into several chunks where each chunk size is 10,000. So we are taking our data set cancer underscore 1m, which has 1 million entries, and we're using that function to generate chunks. And to access each chunk, we use this function next. So after obtaining the chunk, we standardize these chunks so that it's more manageable by our program. After standardizing, our next task is to calculate the gamma matrix, and we use the variable gamma matrix incr to calculate the gamma matrix of each chunk, and then we add the gamma matrix for that chunk to the main variable gamma matrix that would hold the overall gamma matrix of the file. So how we calculate gamma matrix is we first find the transpose of the chunk, and also we add row ones, and then we simply multiply the chunk with the transpose, and then we add the gamma matrix incr to the main variable. After finding the gamma matrix, we find correlation. To find the correlation, we need gamma matrix and dimension. This dimension we are finding from the gamma matrix length. So in this function, we basically find the correlation based on the formula professor taught us in one of his lectures. So we find correlation for each dimension, and we store it in a variable called core_mat, which basically acts like a correlation matrix. And this so the correlation coefficients may be negative as well. So in order to avoid that, we're applying the absolute function so that we are left with just the positive values. And whichever correlation coefficient value is greater than 0.7, we will add it to a list called C, and we would select only the features that are in the list C. So at the end, you can see that we are left with 8 such features whose absolute correlation coefficient was greater than 0.7. We plotted the same, and you can see that there are 8 such features. After finding the correlation matrix, we will be finding the logistic regression using standard gradient descent method. For that, we need to create random weights, and the value of these weights would be anywhere between 0 and 1. And we have set the learning rate to 0.001. We played around different values, but we settled for this as it was giving us more accuracy. And then basically what we do is we use batches, and we get rid of the first row and the last row, which is nothing but the patient IDs and the Y value. And instead of working with the 30 features, we'll be working with just the 8 features, which we determine to be having higher correlation to the Y. So we standardize this data, and then we use it to split the data into X-train, X-test, Y-train, and Y-test. And then basically what we do is we generate a random number, and then based on that random number, we select an instance, and then we calculate the class that this instance belongs to, and then we calculate the updated weights. We then calculate predictions, and if the prediction value is greater than 0.5, we append class 1 to this predictions list, and otherwise we append class 0. If the prediction value is equal to the actual value, we append it to correct matrix, and then we use this correct matrix variable to calculate the accuracy. So as you can see that the accuracy of our model was 94.7%. And then if to compare it with, we used a standard logistic regression using sklearn library. Here we are finding the correlation matrix and again converting it into absolute values and deleting unnecessary rows, and then maintaining a list to add all the classes that has all the features that has correlation coefficient greater than 0.7, and then again using a data and then using it to split into different train and test variables, and then calculating predictions and checking if it is equal to the actual value. So these were the results of our program. The execution time to calculate correlation coefficient using gamma matrix was 11.62 seconds. Execution time to calculate correlation coefficient using existing library was 6.05 seconds. The SGD logistic regression accuracy was 94.7%, whereas the standard logistic regression accuracy was 96.7%. The execution time for logistic regression using gradient descent was 10.6 seconds, whereas the execution time for standard logistic regression was 12.739 seconds. And these are the confusion metrics. And then we just plotted the same confusion matrix. As you can see, the true positive values is 17,698 and the true negative value is 29,708. And these are the false negative and false positive values. We did the same for standard logistic regression. These are the true positive, true negative, and false negative and false positive. Now we'll run the program. As you can see, there is a slight change in the time compared to the Google Colab link and this one, if you're running on server. But that's about it. Thank you.